McMaster, and Feng is a health economist that is like in the area between health economic evaluation and patient-reported outcomes. His work is a lot involved with the EQ5D measures and how to apply it and how to methodologically advance 5D. And today we're going to be discussing about the health utility for coverage decision making. And as we usually do, we're going to introduce ourselves to you, and then you can take it away. So I'm going to start. I'm Dept. I'm a scientist at CICIT.
I'm Nisha Poon. I'm a PhD student with the University of Toronto. So I'm a research librarian at THETA.
Wilson Ryan, IT architect at THETA, and also today's moderator. We do have a couple people online as well joining us. We have Tom Yulee, Senior Consultant, Corporate Major Initiatives at Alberta Health Services. And we also have another gentleman that's joined, Kevin Boiswag, and he get to provide his institution.
I'm Anna Naderby.
I'm Wendy Younger, Director of Technology Assessment.
Nicholas Nzakakis, I'm an assistant professor here at Pharmacy and Biostatistics at THETA.
Teresa Choi, part-time PhD student here in the Leslie Diane faculty.
Sure, yeah, I'm
Kate, project manager at Health Technology Assessment at CICIT. Tracy, I'm Bashir, PhD student at CICIT and HPP.
Mary Ellen Hogan. I'm a PhD student here at faculty.
I'm Hila, research associate at THETA.
I'm Isabel, also a researcher.
Also columnist at St. Michael's Hospital.
Brian, PhD student here at Pharmacy.
I'm health economics at Health Quality at Harris.
I'm Angela Young. I'm from Public Health Ontario.
I'm Emily, also from Public Health.
I'm Clara, I'm a pharmacy.
I'm John Jerome, health economist at McMaster.
All right.
Thanks everyone for coming, and it's a great pleasure to be here, especially a few old friends. But believe it or not, it's my first time in Toronto, and in the past 4 years probably, and it's my first time in UFD. So even though we live very close, so today my talk is about health utility measurement. So many of you, if you're doing economic evaluation, especially model-based economic evaluation, health utility is a recommended outcome measure for this type of evaluation. And many times people use it, just grab it off the shelf without knowing too much about how health utility, measured, how we get the utility values. So today, this topic, primarily, I'm going to just give you an introductory, regarding the health utility measures, and I also will highlight a few key issues which is not solved yet, but hopefully we can, some in the future we can have some development in terms of methodology. So first, let's start with a scientific jargon. So almost 5 years ago, on January 11th, 2011, a group of us received an email from a colleague saying, I wish you all an excellent 11111 day. If it happens to be less than optimal, we will have another on November 1st. So you probably don't know what we are talking about, but that's fine. So one of my objectives is to ensure you understand exactly what we are saying after this talk. So first, the context is a coverage decision making. So probably I don't need to explain what is a coverage decision making. Regarding the allocating limited resources in healthcare, for example, Ontario Benefit Program, that's the decision they are making is coverage decision making. So very often they need to compare across diseases treatments, right? So it's not restricted to one class of drugs, one particular disease. And they're not just looking at the clinical benefit, but also the value for money, cost effectiveness profile for the new treatments. compared to existing treatments. So what is the value in this context? Health utility is a measure of, outcome, as also put into the value metrics. So that's what we're talking about today. So before we talk about health utility, I think it's very important to understand what is the patient-reported outcomes, PRO. So many of you may have heard of this. So this refers to patients' own assessment of their health. So they could, using a health status, referring to the health status or health-related quality of life, or more specifically, functioning symptoms the patient may experience. So it usually comprises a series of structured questions that ask patients about their health from their own point of view. So this is PRO, which a lot of literature published regarding how to measure PROs for the different diseases. You can, if you're interested, you can go to health preference. So this refers to individual's attitude and judgment in the sense of likings or disliking towards alternative health outcomes. Health preference is not the same as patient-reported outcomes. So health preference is often necessary in the context of the decision-making process, because we have alternative choice in order to choose one, and there's a different factors considered. So we probably need to, using a preference in order to make a trade-off and in order to make the final choice. So it's different from patient-reported outcomes. And in this definition, you can see we actually refer to health outcomes. So in order to get a preference, it's not necessary you restrict to patient-reported outcomes. You could use the clinical outcomes if that's, the main characteristics of your study purpose. So here, health preferences is referring broadly, not just the patient-reported outcomes, but also other clinical health outcomes. So there is two different ways to measure health preferences. Ordinal preferences, which is very simple, just, which one is preferred than the other one. One outcome is preferred than the other outcome. This is ordinal preference. Cardinal preferences is, you need to not just know the ordinal information, but also you know the strength of the preferences. So you can tell, what is the distance between the alternative health outcomes, and also tell the strength of the preferences. So health utility actually is cardinal preferences we are eliciting to measure the strength of preferences for health outcomes. So remember, that's a cardinal, not ordinal preferences. And very often in the health economics, we are using, health states to as the main, body. We try to quantify the health utilities for health states to be used in economic evaluation. One important characteristics for health utility is its anchor points. It anchored at 0 for death and 1 for full health. So negative values is possible, referring to health states worse than death. So it can be used to calculate quality adjusted life years in economic evaluation. So, how to measure health utilities. First, we need to develop the health state description, and followed by, preference elicitation process. And then the last step is estimating health utilities. So this is general 3 steps. So first, we need to describe the health states. So there's two ways of doing that. You can develop your own health states description according to your study objectives, the characteristics of the patients, and the disease. Or you can use a pre-developed instrument. So they have a structured questions. You ask those questions to your patients, and then this answers will define the health states for that patient. So this is what we used very often in health economics, multi-attribute utility-based instrument. So there's a few widely used. Health Utility Index was developed at McMaster University back to 1980s. And EQ5D also almost developed around the same time period. Quality of well-being, less frequently we see now it is used in economic evaluation. More frequently we do see the EQ5D or Health Utility Index. These different instruments, they have different questions covered. We use in dimension domain interchangeably, and they have different ways to get the utilities. We will come back later on. And the second step is to elicit preferences. We do have theories and methods. So some of you may heard that very often. Expected utility theory was developed back to 1940s. And then this theory was challenged in 1970s. As a result, there's a new theory called prospect utility theories. And there's a random utility theory, which is more related to the marketing research. So based on some of the theories, there's a different methods developed. For example, standard gamble was developed based on the expected utility theory, try to elicit preferences under risky scenarios. A visual analog scale is quite simple. It just gives you a scale, asks people to place health states on the scale. Time trade-off was developed by McMaster researchers back to 1970s, which is, it's asking people regarding a trade-off using a time duration as a major factor consider, which is was aimed to elicit preferences, close to standard gamble. A discrete choice experiment is more recently people are interested in using that to elicit preferences, which is using a random utility theory. But we do have issues too. So that's I would like to highlight at the end of my talk what are the major weaknesses of the current methods in eliciting preferences. So the final step is estimating health utilities. It depends on which way you do it. Sometimes the estimation could be very simple, just simple addition, subtraction calculations would do. Or it could need some complex modeling in order to estimate the health utilities. General steps for health utility measures. There's you could develop your own health states, according to your target patient population. And then you apply some of the methods, like a standard gamble or time trade-off, in order to elicit preferences from your target patient population. And then you calculate your health utilities. This is what we refer to as direct approach. So the direct comes from you directly elicit preference from your patient population, from your target patient, using some of these established methods. So this is a direct approach. Or alternatively, you don't develop your own health states. You're using some pre-developed instruments, and you use that to define the patient's health states. And then you're using the scoring function comes with these, instrument, and then calculate the health utilities. So the indirect comes from, the scoring function, the preferences elicitation process did not take place directly between you and your target patient population. Is actually coming from a separate research from the separate population. So that's the indirect approach. So you could do either way, but many times indirect approach is much easier and feasible, especially in the clinical research, as well as the some primary study in order to estimate the utilities. And it's also recommended by many government agencies like CARET, NICE. They recommend using the indirect approach may be more feasible for many studies. So now I'm going to talk a little bit more about the recent work we just complete, which is develop a scoring function for the EQ5D. As you can see, even for the indirect approach, you still need a scoring function in order to calculate health utilities. That scoring function is not coming from nowhere. Someone else, if you don't have to do it, but someone else has to do it. So such as health economists like us, we're doing that like very time-consuming process, get the scoring function so you can, convert the response to the 5 questions from your patients to a health utility value. So the EQ5D, it has only 5 questions asking about whether there's any problems in walking about, washing and dressing yourself, doing usual activities, experiencing any pain or discomfort or anxiety and depression. So the use of EQ5D is very simple. You just need to give the questionnaire to your patient and ask them to give you the answers to each of the 5 questions. So they will give you, say, okay, let's say I have a slight problems in walking about. I have no problems in washing and dressing myself. I have moderate problems doing my usual activities. I have severe pain or discomfort. I'm extremely anxious and depressed. So that answers defines a health state for that particular person. And then obviously it's very long if we keep describing the response every time. Instead, we can say the health state from that patient is 2, 1, 3, 4, 5. So now back to the beginning, the email referring to wish everyone 1, 1, 1, 1, 1, what exactly means. So that means we wish everyone has no problems in any of the 5 dimensions covered by the EQ5D. So this may look like a barcode. If you go to the grocery store and then you see nowadays the product has a barcode attached to it. So in order for the cashier to know the value, the dollar value attached to the product, they need to scan the barcode at the cashier and then find out how much it cost. So basically the same thing for the economic evaluations. We get the barcode from individual patients. Now we need to know the value attached to it. What we don't know is a barcode scanner. So the scoring function serves like a barcode scanner, allow us to convert this 5-digit barcode into a health utility value, so you can use into your economic evaluation. But we do run a risk of getting impersonal. But that's a separate issues we need to solve down the road. So this study we just completed is called EQ5D 5-hour evaluation study. So the main purpose is try to develop such a scoring function, work as a barcode scanner in order to convert health states defined by this instrument into a health utility value. So this study, it took us 2 resubmissions to convince CIHR to give us the funding. And also, they cut 10% or 15% right from the beginning. So luckily, we have some additional funding from the Eurocode Research Foundation. As I said, this is a time-consuming process, but I didn't expect that was so time-consuming. It took us 3 years to complete the study. And we included quite a few, preference elicitation methods. We used 2 different types of time trade-off. Composite time trade-off. I'm going to explain what is composite time trade-off, as well as a traditional time trade-off. We also include 2 different types of discrete choice experiment, with or without duration. And the participants come from the general public. This is debatable, but according to current recommendation, the general public seems a reasonable source for health utility in many countries. So especially like those countries are running publicly funded healthcare system. So one argument in favor of the using general public as the source of health utilities is any coverage decision making potentially affect all of us as a taxpayer. So that should be us to give the the preference in order to factor in the coverage decision making. But that's debatable. People are, especially from research point of view, people are interested in looking at what's the difference between the preferences getting from general public versus those getting from patient population. So the final deliverable from this study is a value set. So the value set, what is a value set? So I mentioned a scoring function. So the scoring function is like equations. So you get the response from the 5 questions and put it into the equation, and you will be able to convert that into a utility value. So the value set is actually means, for a list of all health states defined by this instrument, we will have the value set is, have a list of the utility values attached to each of the health states. So that's what we are referring to. The experimental design for this evaluation study, for the time trade-off, for the EQ5D 5-val, it actually defines a total of 3,125 health states. You can do the math yourself. If you get the different number, you let me know. I can show you how numbers was calculated. So we selected 86 out of the 3,125 health states. Obviously, you can see it's not feasible for us to evaluate all 3,000 health states in one single study. So we did have an experimental design to choose a small subset of the health states for the evaluation, which is 86. So we used the block design. Basically, we ask each individual participant to complete 10 health states using a time trade-off. So this is because if we ask too many questions, the quality is going to be decreased. So we don't want to sacrifice our quality, so we make sure the maximum number is 10. And each block had one of the 5 very mild health states. So very mild means it has only 1 2 in the 5-digit. The 2 means slight problem. The rest are no problems. So this each is one of the 5 very mild states. And each block has a 5, 5, 5, 5, the worst health states that can be defined by this instrument. So the rest came from iterative simulation aimed at maximizing D efficiency randomly assigned to each block. So we choose the 80 health states out of these almost 3,000. As I said, we are not just using a composite time trade-off, we're also using a traditional time trade-off. That's
Can we ask questions?
Sure, yeah, for sure.
What is the efficiency?
I have no idea what does that mean. So this is apparently is a, there's a program, there's a mathematician running this and then using this as a statistic or indication for the efficiency of the study design. Eleanor, do you have any explanation about what is a D efficiency exactly about?
Yeah, so you can, for a specific design, you input some Bayesian priors for what you think the parameters are going to be, and then you can run a simulation and get a posterior estimate of the width of the composite. Essentially, it boils down to something like that, but they surround it in lots of mathematical jargon.
Okay, thank you.
Yeah, so this is also an issue I will discuss later. So in the next few years, you're probably going to see quite a lot of EQ5D 5-val evaluation studies. This is as a a strategic research agenda for the Eurocode group, and they're using a standardized protocol. So we also use the standardized protocol, but we use some additional elements in our Canadian evaluation study. So the traditional time trade-off was one of them. So the story is long, but at that time when we started this project, we were not very confident about the performance of the composite TTO. So we said, okay, we have some deliverable, to CRHR. So maybe it's for our best interest and for the safety, we include the traditional time trade-off as well. So we designed that way. So we choose out of these 10 health states in each block, we manually pick 2 severe health states to be valid for the using the traditional time trade-off. I will tell you why we pick 2 severe health states, not some mild health states. When I am just describing the time trade-off process. And for the DCE, discrete choice experimental design, this is a separate design. As part of the standard protocol, we actually picked 390, almost 400 health states, and put into 196 pairs, and then further grouped into 28 blocks. So the numbers looks weird. That's my first reaction when I saw this standardized protocol from the Europe group. 20 blocks, 7 pairs. But anyway, so each patient, each participant was asked to complete 7 pairs of discrete choice questions. So that's the part of the standardized protocol. We also have some additional elements as for our own. So we also want to look at, because for the discrete choice experiment, you get the latent utilities, which is not on the health utility scale, which is not directly, ready for the health utility calculation. You have to do some actual work in order to convert latent utility to health utilities. So we thought, okay, for the discrete choice experiment, we add an additional attribute in the design, which is the duration, which allow us to directly calculate health utility values. So this DCE with duration is some additional designing piece for our own study. So now I'm going to just quickly describe what is the composite TTO, what is the traditional TTO, what is the discrete choice experiment, why did we select the 2 severe health states for our own study to be included for the traditional TTO. So if you look at here, we offer 2 options, basically three. So option A is, is a scenario, someone living in full health, that's the green bar about, full health for 10 years. Option B is living in a health state we want to elicit a preference from that person, which is described here, which is defined by the EQ5L. So also in the 10 years. So option B basically remain constant and not changing if for each individual health states under evaluation. So we ask which one would you prefer, A or B, or A or B, A, B about the same. So if people, so I think this is a, we serve like a validity check, because A is 10 years, the same time duration, full health versus some health states with some impairment. So we expect people to choose A. If not, we're kind of panic. What's going on? What are you thinking about? So if people, let's say we're choosing A, next, all of a sudden, that's all green bar disappeared. So that means the option A changed to immediate death because the number of years reduced down to 0. And the B remained the same. So now we ask which one would you prefer. And then depending on the response, if people prefer B, then the next question, the number of years in option A will increase to 5 years, and going back between 5 years and 0 years, or 5 years, 10 years, depending on the response. So this is a composite TTO for how we measure, how we elicit preferences for those perceived as better than dead. Okay, so the traditional TTO exactly the same. So actually, the composite TTO using exactly the same process as the traditional TTO to elicit a preference for positive health utilities. But what differs between these two, between composite and the traditional time trade-off, is the way they elicit a preference for those perceived as worse than dead. So this, just back to the previous one, if people, let's put it down. So people here, if someone said, okay, now even A is immediate death, B is living for another 10 years in a suboptimal health state, I'm still prefer die immediately instead of living in that situation. So that means we are going to the worse than dead scenario. So this is how traditional time trade-off handles. So if you notice now, option B changed. We moved the immediate death to option B. The health states we just in the previous slide was in option B, now move to option A. Option A is a combination of the two health states. One is the health states used to be in option B. The other one is the full health. So option A is now you live in 5 years in this particular case, particular screen. 5 years in this suboptimal health states, followed by 5 years in full health. That's option A. Or option B, immediately you die. So which one would you prefer? So this is developed as a proxy to Standard Gamble, which is all based on the expected utility theory. So we calculate the expected utility from option A, and we calculate from option B. And then when people hit A and B about the same, the expected utility from option A is equal to that in option B. Then you can do that calculation yourself. Then no matter how you change this, the number of years in living in this suboptimal health states between 0 and 10 years, the final utility you calculated always negative. So that's, we are going to worse than dead scenario, utility is negative. So this is how traditional time trade-off handles this scenario. So the composite time trade-off do it quite differently. So this is if you look at this side, I try to block the other half. This is exactly you see from that screen, right? The option A moves to 0 immediate death, 0 years in immediate death, and option B is living this same health stage for 10 years. Now the composite TTO attached 10 years in full health to both options, option A and option B. So now, why we attached another 10 years in option A is because they already trade off all the 10 years originally provided. So we, in order to going forward, we have to have some additional number of years for them to trade off in order to avoid living in a suboptimal health state. So that's the main reason why we attach. This is also, if you look, there's a called another variant called lead time time trade-off, and then this is basically is coming from the lead time trade-off. So we do that the same. We attach a number of 10 years in full health B as well. So now we ask the same question. Would you prefer to live in option A or option B? So people can continue to trade off the number of years in full health in order to avoid living in this scenario. So that's the composite TTO. So now the difference between composite and the TTO is really in the scenario of worse than dead. So that's why in our design we picked severe health states for the traditional time trade-off, because for the mild, those positive and better than dead, basically the process is exactly the same. So this is the time trade-off process.
Can I ask?
Yeah.
Did you have a hypothesis before you test the two TTOs? I mean, would you expect because from experience, from my experience, I know that the EQ5D, when it goes to negative values that are rated worse than death, things can get really complicated. And I'm wondering whether you use the traditional time trade-off as the correct kind of the gold standard, or you compared it to that, and you compared that to the gold standard, or you were uncertain about which one performs better in the first place.
So first, that situation, messy situation at the worse than dead side, it has not been changed. We're still experiencing the same issue. So when we choose the traditional time trade-off, we actually consider that as kind of a standard approach. We're confident because we have experience, we have the evidence about the performance of the time trade-off at that time, performance regarding the traditional time trade-off. We shouldn't call it a standard, but that's kind of our standard. So at least we know this is one we have confidence to move forward. But we don't have the same level of confidence for the composite TTO. That's why we, in addition to these standard protocol will be used, which are being used worldwide, we add some additional which is a traditional TTO study. So DCE is quite straightforward. You present two different health states. We call it binary discrete choice, and then ask them which one is better. And with the duration, so we still have the health states defined by the EQ5D, but we add additional duration attribute into that. Okay, which is not here. This is just purely defined by the EQ5D, but this one we have additional attribute on the bottom. You probably can see. So
explain a bit more how adding the duration attribute allows you to derive health utility.
Yeah, this one because at the modeling, the duration, the time effect can be modeled as one additional attribute. So that allows us to convert to directly calculate health utilities on the quality adjusted life year metric. So there is a formula why this time duration in it will be able to allow us to calculate utilities directly.
In a discrete choice, utilities aren't anchored in your how can you make that conversion and ensure that your health state is in that way?
Yeah, so that's the main purpose of why we're adding the duration here. That would allow us the additional attribute. We'll put that additional attribute into the model. Actually, we consider the interaction between this Q5 defined the dimensions with the time duration. That would allow us to directly calculate the health utilities. If without that, we won't be able to do that. Using discrete choice, final results we get is still utilities, but it's not on the health utility scale, not on the 0 to 1 scale. But I know, so it's hard to verbally say that, but I can forward you the paper by Nick, which is give you the details about how that calculation works. Yeah.
I have a question. You select around 4 100 health states and around 200 pairs. You random select and match them all manually match.
For the DCE health state, for the health state included in the DCE, is not a random matching. Is matched and then randomly put it into the 28 blocks. The matching is part of the experimental design. But for the time trade-off health states, the 80 health states picked in if it's experimental design, and then randomly put into 10 blocks. So that's where the randomization occurred. So this the participants' demographics from our evaluation study. We used the computer-assisted interviews, and we used the quota sampling in order to try to achieve a representative sample of the Canadian general public. We completed over 1,200 interviews. Participants were recruited from 4 study sites: Vancouver, Hamilton, Montreal, Edmonton, 4 sites. So our full sample, in terms of the age and the gender, very close to the general Canadian population. But for the education, we didn't actually. We have fewer participants in the category of high school or lower education. We have more participants in the category of university of higher education. So that we didn't get very close to the education levels in the general population according to our original plan. And we also applied some exclusion criteria because this is a cognitively challenging process for the time trade-off and for the discrete choice experiment. So people may not give consistent response. So at that time we decided our exclusion criteria is dominance. So if one health state is at least better in dimension, but no worth in any of the rest of dimensions. For example, 2, 1, 1, 1, 1, 1 is better than 3, 1, 1, 1, 1. So we said 2, 1, 1, 1 dominates 3, 1, 1, 1, 1. So we expect the utility for 2, 1, 1, 1, 1 is higher than utility for 3, 1, 1, 1, 1. This is we use it as a criteria to check the consistency. And then, because we have 10 health states in each block, each participant needs to complete 10 health states. So the number of health states with this domination relationship within each block varied from 5 to 8. So we're using the majority rule. So basically, first, and then you also remember, very mild included in every block. So if a participant gave the same or lower score to the very mild health states than to 5, then that's labeled as inconsistent. And if a participant gave the same or lower score to the very mild health states than to the majority of the health states that are dominated by the very mild health states, majority means 3 or 4 out of 5 or 6, 4 out of 7 or 8, 4 or 5 out of 7 or 8. So that's how we define this exclusion criteria. But this is issue is worth discussing later on. So the final score distribution from the time trade-off, as you can see, the red circle is for the composite TTO, the size of the circle representing the number of observations. And the green one is for the traditional time trade-off. As you can see, the red colors appears on the top half of the panel, which means it's more likely appeared on the positive side, which is better than dead health states, and while we see some green on the negative side. So that's the difference between the score distribution for these two different types of time trade-off, which give us, we are concerned about this observation. And look at the agreement between the two. As we can see, it's not surprising. The agreement on the positive side is quite good because they're actually the same process. But we do see the composite time trade-off score consistently higher than the traditional TTO scores for those health states perceived as worse than dead. So we are concerned about the performance of the composite TTO in eliciting preferences for worse than dead health states. So we decided to, in our modeling, to censor all non-positive composite TTO scores. We use all traditional TTO scores, but we use some of the composite TTO scores, we censor all non-positive ones from composite TTO. And we try different model specifications how to represent EQ5D health states. That's always a challenge because we don't have any ways to help us to structure how to present health states. So we use dummy variables to represent a health state. We also use the linear terms, and then in addition some interaction variables. And we tried quite a number of different models, and then we have to specify the criteria. We're going to pick preferred model from a number of options. We use them. We predefined criteria. We first using the face validity. So this face validity is, like I said, if a health state is dominating the other health states, the utility from that health state should be higher than the health states that was dominated. So that's the first criteria. The second one is we're using the prediction precision, which is mean absolute error between the observed versus the predicted one. And also, if we have the same multiple models perform the same according to the first two criteria, and then we choose those fewer variables in the model. So finally, the preferred model, we choose this, using a term, which is this first 5 terms, linear term, and then we also add, additional terms accounting for the fact that the severe or extreme impact on the health utility. So this is representing level 4, level 5. If a health state has any, severe or extreme impairments, that would indicate for that additional variable. And we also, because the multiple level 4, level 5 impact, the marginal impact from the severe extreme impairments got to be, not getting less and less. So we correct for that nonlinear fact here using this additional term, which is the number of the total number of level 4, level 5 minus 1 and squared. So this is our the highlighted model is our preferred model, which is used to calculate the value set for the EQ5D 5L in Canada. So this is some sensitivity analysis. I won't be able to go through details. I'm just going to skip. And then, yeah, our paper finally published. So this is to give you an example how to use our model results to calculate the health utility for any health states defined by this instrument. You don't have to do that because we will have the full value set available. You just need to using your look for function in Excel to find out the corresponding utility value for health states. But this just gives you an idea how utility value for particular health states is calculated. So basically the process, now we take a closer look how we get health utility measured. First, we ask people to imagine living in the health states. So this is a general population. We present, hypothetical impaired health states. We ask them to imagine living in that situation, and we observe their behavior using our predefined exercise, and then we make a prediction. So that's how we arrive at health utilities. So the issue is first the designing. If we look at the health states we picked, and then for both a time trade-off and discrete choice experiment, it's very hard. If you do that yourself, I did that myself before we started this project. I found it's very hard to make a trade-off because there's so many levels, so many dimensions involved in the trade-off, makes it very cognitively challenging in order to have the final, say, A and B are the same, or which one is preferred in discrete choice. So this, from one hand, we using some mathematical function using a D efficiency as the criteria to come up with some, a list of health states to be valued. But what does that mean to us? What does that mean to our participant? In reality, we don't observe that so many more than 3 or 4, 5 trade-offs in the same time in the clinical scenario. That's not very often we see. Very often we do see like 1 or 2 improvement in the dimension of the EQ5D, not 4 or 5 trade-offs. So are we overcomplicate our study design? Because that does have the implication. Because people have a hard time to make that to complete the test. The quality of the data could be in jeopardy, right? So this is the issue for, I think, not just for our Canadian valuation study, but also for many other studies, not just for EQ5D, for SF6D, for other instruments as well. So this, if you try to do that yourself, try to pick a, discrete choice experiment is thought to be very straightforward and easy. But if we ask people to make a choice, like let's say some patient can go to a hip replacement, elective hip replacement tomorrow, but you need to pay $5,000 extra versus another choice. You have to wait for 2 months, but you don't have to pay. So that's discrete choice is easy for people to understand to answer. But if we put it into the scenarios of using the health states of EQ5D and it involves the trade-off for all 5 dimensions, it's very hard to do that. It's very hard to say which one you prefer. So this is the complex side of the study design. The other thing is the way we ask people to give us the preferences. Also, is that, if a person asks, how does it feel to misunderstand how you might think about not knowing what to believe? So how people respond to that question? So we design our study, is not as terrible as this question, but it's also very, very complex regarding, involving the time duration, a trade-off between 5 dimensions of the EQ5D. And then at the end, we define, okay, some of people, you give us a wrong answer, inconsistent, we try to exclude them. So this is a debatable issue, even though in our study, we try to exclude a small proportion of participants' response based on the inconsistency we defined upfront. But this is contentious issues. So many studies, they don't exclude anyone, even though we notice there's a kind of, according to our definition, apparently inconsistent response. They include everyone in the final modeling. We did that in our scientific analysis. So I have to be quick. So Petra's keep reminding me. So I should have a 5 minutes more, right? Because you asked me to wait for an extra 5 minutes in the beginning. Anyway, so the other issue is about worse than being dead. So this is, according to definition, we allow negative utility values. So the one part is, actually we found from our qualitative interview for some of the participants in using the standard protocol, give us the feedback about how they perceive, those terrible health states. They have no problem say that's worse than dead. I probably prefer dying. But when we ask them, okay, how can you tell me, actually quantify the strength of the preference? How far away from death? Death is 0. How far away from death? So they have a hard time to do that. So then we felt, okay, do we, nowadays we do incorporate negative values in our, actually that's one of the very, important issues when we look at the distribution of the score, whether we see any negative values. Do we really need to, quantify, negative utilities? As many people from our interview, it's very hard for them to quantify the distance on the utility scale, health state perceived, no problem perceived as worse than dead from death. The other issue is who we should get preference from. As I said, when I mentioned the design of the study, we're using the general public, but it's this is an issue. Some people are raised. We want to use a patient. How different is that going to be? We don't have the answer for that, but if you're interested, you could try to look for those literature, try to compare the difference in preferences between patients and the general public. So finally, the truth is, nobody knows the truth. So nobody knows what is the truth, what's the true preference. So that's why we still can, the economists can still make a living from doing our study, but we know the truth about how we are doing this type of research, how we are measuring health utilities. We are observing behaviors of a group of people through hypothetical scenarios, and we are assuming all of us would have the same behaviors in the future, now and in the future. And then we're using these behaviors we observed in the hypothetical scenarios for real decision making. So there are a lot of issues that needs to be solved in the future in terms of the methodology, in terms of the, for example, how to design a study, how to describe health states, etc. So I'm just going to say thank you for coming to the rounds, which is quite a lot of people. Because at McMaster, we used to have a rounds, just have few people show up. I used to organize the rounds at McMaster. Make me, as organizer, feel terrible for the lecture. So today I feel very good, and I wish everyone has a 11111 in 2016. Thank you.
Thank you, Feng.
Wow, I finished right at 1.
That's
according to